Welcome back. So let us now move into the next 5 questions. That is question number 36 to question number 40 of the second chapter of 11th class NCERT chemistry back exercise, that is structure of atom. So let us now see what is the statement for question number 36 and solve it. All right. So question number 36 states that 2 multiplied by 10 raised to the power 8 atoms of carbon are arranged side by side. Question number 36. 2 multiplied by 10 raised to the power 8 carbon atoms are there, and they have been arranged along a length side by side, just like the previous question. This is a similar question to that. Okay, so let's see what we need to find out here. Calculate the radius of carbon atom if the length of this arrangement is 2.4 centimeter. The length is 2.4 centimeter, and we need to find out what will be the radius of the carbon atom. Okay. So we have been given the total number of carbon atoms. We have 2 into 10 raised to the power 8. Okay. And they are covering 2.4 centimeter length. So if we find out what will be the length covered by one atom, one carbon atom, that will give the diameter. Just like in the previous question, it will give the diameter. Okay. So then we will make it half. We need to find out the radius, I think. Okay. So we will make it half. It will be equal to the radius. So we can just write length covered by 2 into 10 raised to the power 8 carbon atoms is equal to 2.4 centimeter. Therefore, length covered by one carbon atom will be equal to 2.4 centimeter upon 2 multiplied by 10 raised to the power 8. So it will be equal to 1.2 multiplied by 10 raised to the power minus 8 centimeter. So this will be equal to the diameter of carbon atom. Okay, we need to find out the radius. So radius is equal to half of diameter upon 2. So it will be 1.6 into 10 raised to the 1.2 into 10 raised to the power minus 8 centimeter upon 2. So it will be 0.6 into 10 raised to the power minus 8 centimeter. So now you can just convert it into scientific notation. I have given you many a times how to convert this into scientific notation. So just check it out if you are able to. Okay. And if you are not able to, you can revise it. Let us now move into next question, the question number 37. Question number 37 states that the diameter of a zinc atom is 2.6 angstrom. Diameter of zinc atom is 2.6 angstrom. We need to find out radius of zinc atom in picometer. Okay, so we have been given the diameter in angstrom and we need to find out the radius in picometer. So first of all, we can just write diameter is equal to 2.6 multiplied by 10 raised to the power minus 10 meter. Or I can just write it as, okay, we have been given diameter and we need to find out radius. First, let us convert it into radius. So radius will be equal to 2.6 upon 2 multiplied by 10 raised to the power minus 10 meter. So it will be 1.3 into 10 raised to the power minus 10 meter. So this will be the radius of zinc atom. Okay. Now we need to convert this value into picometer. So I just can write 1.3 into 10 raised to the power minus 10 meter. It will be equal to 1.3 into 10 raised to the power minus 10 meter multiplied by. Now I need to cancel meter with meter and I need to convert this into picometer. So I just can write here 1 picometer upon, if I multiply and divide this value with the same value, it will not make any difference to the value. So I'm writing here 1 picometer, but on the denominator, I will be writing it in terms of meter. So 1 picometer is equal to 10 raised to the power minus 12 meter. Okay, so this will get cancelled and this will come out to be equal to 1.3 multiplied by 10 raised to the power. So here we have minus 10, it will become plus 12 when it will go to the numerator. So it will become this value 1.3 into 10 raised to the power 2 picometer. So this will be the radius of the zinc atom. Now, what is the second part of this question? In the second part of the question, we need to find out the number of atoms present in a length of 1.6 centimeter. Okay, now again we need to convert the units. Now we have been given the total length equal to 1.6 centimeter, and in this very length we need to find out how many zinc atoms can be arranged. Okay, now diameter is equal to this much. Length covered by one zinc atom is equal to diameter of the zinc atom. Okay, so it is equal to 2.6 into 10 raised to the power minus 10 meter. Now let us first convert it into centimeter. So 2.6 into 10 raised to the power minus 10 meter. Here I can write 100 centimeter because in 1 meter there are 100 centimeters. So I can just write it this way. So it will be equal to 2.6 into 10 raised to the power minus 8 centimeter. Okay, so we can just write in 2.6 into 10 raised to the power minus 8 centimeter, number of zinc atoms is equal to 1. Therefore, in 1.6 into 10 raised to the power, 1.6 centimeter, not 10 raised to the power, there is no power. Number of zinc atoms will be equal to 1 upon 2.6 into 10 raised to the power minus 8 centimeter multiplied by 1.6 centimeter. So this will come out to be equal to 1.6 divided by 2.6 equal to 0.615 into 10 raised to the power 8 zinc atoms. Now you can just convert it into scientific notation. 6.15 into whatever is the power, you just need to write it. And write it in the comment section below also. What will be the, how you will write the scientific notation of this very term, so that I can know that you are actually learning the things. Okay, so now let us move into the next question, that is question number 38. Have we covered all the parts of this? Yes. So let us now move into question number 38. So the question number 38 says a certain particle carries 2.5 multiplied by 10 raised to the power minus 16 coulomb of static electric charge. Static electric charge means which is not moving. Okay. Okay. So question number 38. So the charge that has been given, that the particle contains charge equal to 2.5 multiplied by 10 raised to the power minus 16 coulomb. Calculate the number of electrons present in it. So negative charge, it will be due to electrons. So we need to find out if this much charge is there, how many electrons will produce this much charge. Simple. Okay. So what is the charge on one electron? 1.602 into 10 raised to the power minus 19 coulomb is equal to 1 electron. Okay, therefore 2.5 multiplied by 10 raised to the power minus 16 coulomb is equal to 1 upon 1.602 into 10 raised to the power minus 19 multiplied by 2.5 into 10 raised to the power minus 16. So it will come out to be equal to 2.5 divided by 1.602. It is coming out to be equal to 1.56 into 10 raised to the power 3 electrons. So these many electrons are required to produce the given charge. Okay, so let us now move into question number 39. Let's see what is the statement for this question. Okay, in Millikan's experiment, static electric charge on the oil drops has been obtained by shining X-rays. Okay, if the static charge on the oil drop is minus 1.282 into 10 raised to the power minus 18 coulomb, calculate the number of electrons present on it. Similar question, just values are different. Okay, now we have been given that the total charge is minus 1.282 into 10 raised to the power minus 18 coulomb. Okay, and we need to find out how many electrons will produce this much charge. Okay, so we can just write minus 1.602 into 10 raised to the power minus 19 coulomb is equal to 1 electron. Therefore, minus 1.282 into 10 raised to the power minus 18 coulomb is equal to 1 upon minus, or we can just say 1 upon minus 1.602 into 10 raised to the power minus 19. Yeah, here we can just write 1.282 into 10 raised to the power minus 18. So it will be equal to 1.28 divided by 1.602. It is coming out to be equal to 0.799, or we can take 0.8 multiplied by 10 raised to the power. Here it will be 10 raised to the power 1, because 19, when it will go in the numerator, it will become plus 19. So it will be equal to 8. So 8 electrons will be present on the oil droplet, which are producing this much charge. Right? Hope this is clear to you. Let us now move into question number 40. Question number 40. So let us see what is the statement for this question. Okay, in Rutherford's experiment, generally the thin foil of heavy atoms like gold, platinum, etc. have been used to be bombarded by the alpha particles. Okay, so we used gold, platinum. So these heavy metals are used in Rutherford's experiment. Okay, if thin foil of light atoms, okay, these are the heavy atoms. If thin foil of light atoms like aluminium, etc. is used, what difference would be observed from the previous results? Okay, so this simple statement is that in place of gold or platinum, that is in place of heavy atoms, if the thin sheet of light atoms are used, what will be the impact on the results? Okay, now if you remember what was the Rutherford's experiment, in that experiment, if you are not sure about it, you can just read it. If I say this is the gold atom, and from this source, there is a slit, all the setup you can just see. And this is the source of alpha particles, and the alpha particles are going like this. And when they are bombarding with the atoms of the heavy metal, what is happening is that many of the alpha particles, they just returned back after bombarding like this. They retraced the path. Many of the alpha particles, they got small deflections of the path. So small deflection. Now, what is the meaning of small deflection? Actually, the direction of alpha particle is this. Now, what is the angle of deflection? By this angle, it has got deflected. Now, this is a small angle. Okay. Now, why is this happening? Why the deflection is small, and why there is complete retracing of the path? Just because of this heavy center nucleus, which is having, this is heavy nucleus, because the atom is heavy nucleus, so large mass is there, and there is high positive charge. Now, because of this, what happens when the alpha particle, they bombard with the nucleus, or they are passing close to the nucleus, they are getting deflected by either small angles, or they are retracing the path. Okay, now what happens if we take the light particles? What will happen? Their nucleus is going to be light. Okay, the mass will be less and charge will be lesser. Now the number of alpha particles which will be showing this similar type of behavior, that is retracing of the path and deflection by small angles, it will be very small. Now if it is very small, it will become difficult to detect these alpha particles which are showing this behavior. Now, if the number of alpha particles showing this behavior, it will decrease. The observations will be difficult. So, the building of the results will be difficult. Okay, so this is the simple reason why heavy atoms are used, not the light atoms. Hope this is clear to you, right? So, if you have any doubts in any of the questions we have discussed in the previous videos or in this very video, you just can write in the comment section below under that particular video that you are facing the problem in if you are facing the problem in any particular question. Okay, and if you want to learn the concepts of chemistry in depth, you can join my live classes, and there I will be covering all the syllabus and all the basic concepts, so that you get all the clarity and you get confidence about appearing in your entrance exams, as well as you get above 90% marks in your final exams, in your boards as well as in your 11th class final exams. So if you have liked it, if you are getting conceptual clarity from these videos, just like these videos, subscribe to the channel so that you can get notified about the new videos, and share these videos with other fellow friends of yours, because they should also get benefited. If they are facing any kind of problem in chemistry, we should be there to help them to solve that out. All right. I will see you in the next video with next 5 questions.